Okay, I'm happy to have you in class today. All right, you're welcome to the Supernovas TV, where we make maths and science quite easy. Okay, if you're finding subjects like physics, chemistry, mathematics difficult, you're in the right place. Today we're looking at binary operations. Okay, in binary operations, we are going to look at the definition of binary operation and some other terminologies and how to simplify problems on binary operation. The first thing we look at is what is binary operation. Okay, we can say it's a set of rules, or yes, these are rules, okay, of combination. Can be a rule of combination of two elements, okay, or two elements in a non-empty set. In a non-empty set. Now we look at some terminologies under this topic and calculations. The closure property, or yeah, under binary operation, we're looking at the closure property. We'll look at the next one, commutative property. There are some concepts under this topic that we need to understand. Okay, we have associative property. We also have distributive property. Okay, and of course we have identity elements. Identity elements. And we have the inverse elements. Okay. Now let's look at the first one, closure property. We're looking at closure property. Okay, I'll rub off these other ones. So we'll go over to closure property. Okay, now in closure property, we are looking at a set, okay, closed under an operation, okay, depending on the nature of the set. Let's say Z, okay, is a set of positive integers. Okay, now we want to look at the operations that ensures Z is a closed set. That is, it lies within the values lie within the range of positive integers. Okay, now if we have Z as 3, 5, for instance. Okay, now positive integers. We can see that for addition, 3 plus 5, we have plus 8. Therefore, plus sign is what? Closed. Okay, the set Z is closed under the operation addition. If we look at 3 times 5, we get 15 plus 15. It is closed under the operation multiplication. If we look at division, 3 divided by 5, you can also say this is not really close because the integers should be whole numbers. Okay, so we cannot really say it is closed under division. Okay, we will get 0. 3 over 5 will give us 0.6. Okay, this is not closed under the operation, or the set is not closed under division. And if we have 3 minus 5, this will give us minus what? 2. This is not a positive integer. Okay, therefore it is not closed under the operation subtraction or division. It means Z is closed. Okay, that's the closure property now, under addition and subtraction, but it is not closed under division and what? Subtraction. I hope you have the idea now. And let's go to commutative property. I'll rub this off right now. commutative property. What is the commutative property? It shows us that if two elements are interchanged, okay, in a function, they are equal. Okay, depends on the operation we are carrying out. Okay, so let's look at this. A function b equal, okay, be a function of a. Now let's look at some numbers we can use. Okay, if we have a as 2 and b as 3, okay, let's look on addition. We'll interchange them right now. So we have 2 plus 3 equal 3 plus 2, 5 equal 5. This is correct. So the operation, okay, is commutative. Yeah, this, or the form is commutative under addition. Okay, addition. Then let's look at multiplication. 3 times 2 equal 2 times 3. Okay, this is 6 and this is equal to 6, correct? So it is commutative, okay, under multiplication too. But now let's look at subtraction. 2 or 3 now. 3 minus 2 is not equal to 2 minus 3, because this is 1 and this is minus 1. So we say this is not commutative, okay, or this operation now is not commutative under what? Subtraction. This operation is not commutative under what? Subtraction. And also division, it will not give us the same answer. So most of the time we only have addition and multiplication being what? Commutative. I hope you understand. All right, now let's go over to associative property. I think in the next class we'll look at the associative property, because of we'll look at this other property in the next class, associative property. Okay, so kindly join us in the next class. Thank you for watching, for following us so far. I hope you've learned something. Okay, thank you so much.